Hello Gophers and welcome back to part 12 of our Introduction to Go. In this video, we'll be learning about functions. Before we move forward, please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications of any new videos that we put forward. All this while, when we were doing some basic programming like understanding loops or conditional statement, declaring variable, those stuff, we were actually doing things in a function. Now, that function's name is main. Main function is a very special function because Go will actually start its execution from this particular function when it encounters this function in the main package. So, how can we declare a function and what are functions? Function is nothing but a set of similar statements or logical statements grouped together. Let's say, for example, making a tea will have a particular set of instructions involved in it, like take water, take milk, and all those things that you need to do while making a tea. So making a tea would be a function which will have a set of statements that will be needed to be executed on a grouping fashion. So all those statements will be executed together every time. You might have some variations like add ginger to it. So those variables can be an input to the function, and we'll discuss how we can pass those inputs and change some flow in the functions. So now how can we declare a function? To declare a function, you should use the keyword func. So any name of the function will always be from capital or small depending on what access level do you want to use for that function. So if you have used a capital case first character, then the function will have a public scope and it will be used it can be accessed from the other packages as well who imports the particular package in which the function is. So after that, we have a parenthesis which will contain all the input parameters that we need to supply to the function to change the flow of the function. Then is a curly bracket start and a curly bracket end. Now you need to note that the curly bracket starting should be in the same line where you have declared the name of the function. It cannot be in the other line as you do in other programming language. So in other programming language, it's completely optional where you can use it in the same line as I have given here, or you can take this function starting of curly bracket in next line, but in code this is not allowed. You have to use the starting of curly bracket in the same line where you have declared the name of the function. Now, and the ending is definitely the place where you will end every logic that is contained in the function. So this is a main function, and the only thing that I want to do right now with the main function is print a line which says hello world. So this is the basic program that you can see when you go to Go Playground. There is this small example. Definitely world is at times written in Chinese as well. So no issues with that. So this is a simple print function which will only print one single statement, and let's start and run this. So it is printing this. Now let's say I want to create another function which does something like printing uh, goodbye to you. So function, let's say end program. So whenever the program is getting ended, I want to call this function. So one key thumb rule that you need to keep in mind is the function name should be very descriptive, and it should not be something like A, B, or C. So because that will not give an insight of what the function is actually doing. So you should keep the function name small but very descriptive. And if in case you feel that the name is not enough, so you can put some comments over the function so that any person who is coming to your program will be easily understanding what the function is for and what are the basic logical statements that you have put forward and what were the test cases that you might have executed. So in this statement fmt.println program ended. So this is a function. Now I have declared a function, but when I run the program, I will not see this output. Why? Why I'm not seeing this output? Why it was not executed? Because this function is just declared but never used. So you need to call this function from the main program. So I will call this function. So to call the function, we'll just mention the name of the function and the parenthesis. And these parentheses should contain the input parameters that needs to be supplied. So currently we don't have any input parameter that end program is expecting. So I'm passing nothing over here. Now let's see and run this program. So you can see hello world and then the program ended successfully, which was the the statement that was written in the end program function. So now let's start by analyzing how we can pass some variables or values into the function. So let's say I will create a function which will find if the number is prime or not. Let's see. Uh, Check prime. So what inputs do you feel that should come into the function? It should be the number which I want to check if it is a prime or not. So I will accept as int 32. Let's say we will accept an int 32, and the function should also return some value. Now what is a return value, that we'll analyze in a bit, but let's start understanding how we can pass some value to function and write some logic in it. I'll remove this function to the end so that we have ample space to check at the program. So I have taken an input as num. Now with num, how we can check prime? I'll not go into algorithms, very fancy algorithms. We'll take a very basic approach and we'll see. So I have a flag variable that is of type bool, and where flag is bool, and let's assign value as false. So I will be using method of contradiction where I will see that if the number is actually prime or not. So I'll always take into account that whatever number is given to me is prime. So I will set this flag as true. But if this flag comes as false anytime the number is not prime. So the basic rule that you need to see in prime number is the number should be divisible only by 1 and itself, nothing apart from that. So let's start by a for loop, and where the iteration should begin with 2, because 1 we know every number is divisible by 1. So why should we start by dividing by 2? Uh, Now let's see till what count do you want to go. I want to go a number less than the num. So I don't want to go till num because num is something which will divide itself anyways. So we'll not go to num, we'll have a less than, not less than equal to. Now if num modulus I double equal to 0, that means there is a number starting from 2 and 1 less than itself which has actually divided the number itself. So that will make this number as non-prime. So flag becomes false, and I should definitely break this off because I should not go ahead and check for more values that will actually divide this. So there is no need to check for more values. Even if one number have we encountered where it is dividing the num, That's enough for us to understand that this is not prime. Break. So I'll break. So this break keyword will break the nearest looping statement, that is pause statement. Now over here we can check if flag equal to true. So as this is a boolean variable, we don't have to compare it with true or compare it with false. We can directly go ahead and give condition. So fmt dot print f number percentage d is a prime number, and num will mention else is not prime number. So this is what we are intended to do now. Now there is an issue which, because Go is not converting numbers on its own. So here it says that this is of type integer and this is of type int32. So what we can do is we can declare this as var int32 and assign it a variable value. So this makes this as int32 and will help us. So to be very sure, I'll take this out of this statement so that things are very clear. Now let's run this program and see how this behaves. Now again, you have not got the output because I forgot to call this function. Now when I want to call this function, it is expecting an int32 number. So I should declare an int32 number where n is small and int32 is equal to, let's say, 8, and I will pass this to number, the prime, the check prime method. So now let's run this. So it says number 8 is not prime, and we have encountered the program as ended because we have not given a end line feed over here, so to give a clear indication that the line has ended. So 8 is not prime, which we already know that A is not prime. Let's see if we can. It is checking for 7. 7 should be prime. So number 7 is prime number. So that's one part of your function approach where we have enclosed this in this complete prime number logic into one conditioning block. Now this is what also important when you have large set of programs where checking prime is one part, and at times you have cases where you need to check prime on multiple stages of your program. So you don't have to repeat the logic. If you might have not used this approach, you might have copied this complete logic over here and then checked. And then if in case like 10, 15 lines down, you again want to check the prime, you might have repeated the logic. So this will help you follow the do not repeat yourself principle of your software development. And also, this is very clean approach because if someone goes into the main program and starts reading it, he will understand, yeah, okay, here we are checking if this number is actually prime or not, and then we are printing something for end program. Now, end program, I also want to create another program, another function because there might be many things that you want to do when your program ends. Like if it is ending abruptly or something, you might want to send some email to your developers that the program has actually ended. Or if it is ending, you might want to say goodbye to the user. So that depends on the case to case. So that is why I create this end program method separately. Now you might argue that this is something that we have to put deliberately after all the logic that we have written. But there is one more way that we'll be discussing in further videos where we can use a defer keyword, and that differ can be then we can configure this end program over here in the first line, so that you don't miss on uh, juggling up with the logic and writing some logic after the end program. So that can be done, but that is something that we'll be discussing in the further videos. Now let's understand how we can pass multiple values. So let's say I want a function to be created where I want to check if a number is divisible by some other number or not. So let's say func check check divisibility. Now here I want two numbers to be passed in. So I can pass like uh, num of type in32 and then divisor of type in32. Now this is a function which will check if num modulus divisor double equal to 0, then fmt dot printf number percentage d is divisible by percentage d, and not to miss a line feed num and divisor. Now this is something that we have printed. In case of success, we'll have is not divisible by this divisor. Now when we want to check this divisibility, we will call this function with two input parameters where number, and then I want to check if it is uh, divided by, let's say, 3. So in 32 I'll say 3 to be sure that whatever is passed is of type same that is expected. I have passed this. So now let's go ahead and run this program. So it says number 7 is not divisible by 3, which we are aware of. So now Go has given some sugar coated syntaxes where it says that if you have like 4, 5, or even 2 variables that you pass of same type, you can remove declaring the type again and again for both the variables. So over here, num and divisor both will be of type int32. So this helps you reducing the number of characters that you type in your program. So this is how we can pass multiple variables. You can even pass another data type like str of type string or anything that you want in the function that is required as an input from the main program or from other programs. So now this can also be used in your check prime, but right now if I call this every time over here, I will get an output printed on the screen. So instead of printing something from this printing logic should be something that should be residing in the calling function. This function's responsibility is just to tell the calling function that if this number is divided by this or not, is divisible by this or not. It should just send yes or no to the calling function. Nothing else it should do. Everything else should be the part of the calling function, what decision it has to take, whether it has to print it or it has to do some more logic based on it. So we'll see how we can pass some value from one function to the calling function. So before we move forward and understand how we can pass value from a function to another function, or let's say how we can take some value out from a function to the calling function and pass the result to the calling function, we'll take one step back and let's understand one more critical logic and functional approach, that is, are the value passed by references or not? Now, by references, I mean that if the calling function changes any value in this, will that be reflected in the main function or not, or the callee function or not? So let's understand this. Now, what we'll do is in check prime, I'll change the value of number, and let's see, let's say number equal to 8. Every time I will mention this. And so if the numbers are passed with a reference variable, then ideally what should happen is printf percentage s value of num of num. So ideally what should happen is the same value that is updated over there in the function check prime should be reflected over here in this. Now this should be percentage t. So it should ideally be reflected over here, and this number should be printed as 8 if these values are passed by references. So now let's go ahead and print this program. So if you can see, number 8 is not prime because this function is checking 8 as prime or not, because we have changed the value of num. But when this function gets finished and we again try and print the value of num, it is still 7. So that means any value that is passed inside a function will be passed by value, not their reference. But we should be very careful when we are using a slice or maps, because for those two the reference will be passed because they are themselves some reference to some variable. So, so as we have discussed in slice is actually a reference to underlined array. So if we pass a slice and we change something in the slice over here in the function, then the corresponding change will be reflected in the parent function as well. So we should be very careful in passing slices or maps in the function so that we don't end up in having some trouble in debugging and those things. Now, we will also discuss one more important case, that is periodic variables in Go. That means right now when you see at the program, the input parameters are a limited number of parameters that you can pass. Now, how can we make a program where we can pass n number of similar data types? So to do that, let's say I have a function, let's say sum. Now I want the calling function to have a liberty of passing n number of variable as input to the sum so that we can sum all that together and give an output. So to do that, what I can do is I can declare a variable, then three dots and the type of data that needs to be passed as a slice. So this will be considered as a slice of int32. Now to check that, so I have some, and some should be in 32. So uh, for key and value, um, range of value, I will do sum is equal to sum plus value. So this is how we will keep adding those numbers, and fmt.printf sum is percentage t and sum. Now let's call this function after we have checked the divisibility. So over here I want to pass 2 int 32. So let's say 2 comma 3, and let's see if this is running fine. So the sum is 5. Now if I pass one more variable, let's say 4, then let's say 5. We're passing now 4 variables in the same function. So this gives an output of 14. Now if you want also total number received, received length of values. Now let's receive word percentage d, and their sum is. Now if you see, we have got total number received were 4 and their sum is 14. Now if I remove one variable from this and then see, total number received were 3 and their sum is 9. So this is how you can pass n number of variables to a function. But if you need a string variable specifically to be passed, or let's say I want a number exactly to be passed, not in the slice. So uh, let's say message of type string has to be passed. So in that case, hello will be passed, and I want to print that as over here. So in this case, you cannot pass this variable over here after the variadic variables, because in that way Go program will not understand where to end passing this into variadic and when to start passing the actual solid parameters. So you should always have the variadic parameters in the end of the parenthesis or the input parameter declaration, so that Go is very sure that yeah, this is something, when you pass, this is something that needs to be passed in the message, and all this that is remaining should pass to value. So this is how we can pass n number of parameters to a functions in Go. Now let's start by understanding how we can take some value out from a function. To take out from a function some variable or some value from a function, what you can do is, let's say we'll modify the check divisibility method only. So that should always have a output type first declared in the first place. So I have an output type, let's say I only have a boolean output type where it says yes or no. So in that case, what I can do is return true, and in this case we can return as false. Now wherever this check divisibility is being called, it will accept a parameter and take it into the variable. So is divisible, I created a variable which will definitely be of type boolean or bool, because that's the output type of this function. Now here I can give in logic saying, sorry, if is divisible, fmt dot print f number percentage d is divisible by percentage d, and where I'll mention number by 3. sorry, else I will mention is not divisible by 3. Now if I run this program, this should result in the same output as earlier. I have messed up line speed, that is why it is mixing with some other lines. Now if you see, number 7 is not divisible by number 3. Before that we had this value printed, and after that we have sum printed. So hello, today total number of number received were 3 and those things. So this is how this is done. A value is being passed out from a function. Now this function, the same function, can be used in check prime also. So to, to do that, what we can do is check divisibility, and the main variable that needs to be checked is this, and by which number it should get divided is this. So here flag is equal to whatever comes out, and if flag is false, then we need to break, and this should remain same. Okay, I have, okay, now let's run this. So if you see, number 7 a is not a prime, it gives as false, and if it is false, so there might be some logical issue. Okay, so the logic that I have made wrong is this should be considered as false, because we will consider that the number is not divisible by any number, and we'll check divisibility. If this comes as true, we'll break, and if this is true, then number is not prime, otherwise number will remain prime. So this is a small change that we need to do when you write a conditional, uh, sorry, functional approach, but that's up to you. How do you design the functions? So it says 7 is a prime number. Now let's pass 8 into it, and we'll remove this line. Now let's pass 8. So 8 is not prime, and it is not divisible by 3. That was the second thing that we were trying to execute. So this is how you can take out one parameter, but in case you want to have like multiple parameters to be driven out of the function, so we can take that as well. So let's consider that check prime was supposed to return if the number is prime or not, and also return how many numbers, by how many numbers it was actually divisible apart from one and itself. So I will have a variable which says where count, and it is of type int, which has a value of 0. Okay, and every time the number is divisible by some number and divisibility is true, I will increment the count. And now I will remove this logic and offload this to the calling function, and let's flag. Now I will return, sorry, boolean, and let's say int value. Two values I will have to return from this function. So when you want to return two values from a function, you will enclose those types in a bracket so that Go compiler knows, okay, this is a pair of return types that it has to follow. Now after this program has ended this logic, that means, so we'll return value of flag. Now value of flag should be uh, exact return that should represent that if the number is prime or not. Over here, false means it is prime. That should not be the exact return type that anyone would expect out of prime number, prime check prime method. So we'll revert the logic so that anyone who gets an output and sees flag is true, that means yeah, this number has to be true. So we have reverted this. And the second thing that we want to return is count. So we have returned two values from the function. Now, whenever I'm accessing this, so says it says it should accept cannot initialize one variable with two values compiler. So what I can do is I can have count over here, and this count also can be printed is not a prime number, and over here I'll mention that it was divisible by other number. So I should mention the count. So now if we see and run this program, so it says 8 is not prime, it was divisible by two other numbers. And what two other number can it be? 2 and 4, definitely. So this is one thing, and then 8 is not divisible by this. So you can also have an list of, sorry, a slice of int to be returned to the parent function. So the parent function can have all the numbers by which it was divisible. So in that case, I will declare a slice of int. This will be, let's say, I will declare it as slice of int and equal to make, I'll remove this, make slice, and minimum size should be 1, but maximum can go up to the number of num minus 2, because num minus 2 means 1 will not be considered and num itself should not be considered. This is the max capacity that will be there. So count, so for this append count, and what value should be appended? It should be appended with I. So I should be appended, and okay, I is of type int32. We'll have to convert all to int32 so that it does not shout for that. The append function, okay, and count equal to this thing, and now this will keep appending the values that are dividing the number, and in the calling function this count will be received, and we can have values, all values to be printed. So see, it is divisible by 2, 4, because 0 is coming because we had this initialized. So first value was always initialized for this, and then append happened. Now I initialized it with a length of 0. That means I said to Go that you don't initialize any value, but you keep a capacity of number minus 2. And now we'll keep appending one value to the slice that gives me 2 and 4 other numbers. So the 8 was divisible by 2 and 4. Now when we pass 7, now when we pass 7, so it says 7 is not prime, it was divisible by this. So I think there is some mistake with 7. So flag is false. Okay, so we got the error, and if you can see the count, if the length of count variable is greater than 0, then the number is not prime. We should not rely on a flag. That that's very clear. So this is a very clear indication that if count is greater than uh, 0, the length of count is greater than 0, that means the number is not prime. So now let's start by printing it and see. So 8 is not prime and it is divisible by 2 and 4. Let's say 7. Let's print this. 7 is a prime number. So this is about how we can pass multiple values from a function and how we can pass in many values to a function using the variadic approach. Now let's also understand how we can pass functions inside a function. In Go, functions are also treated as first-class citizens. That means a function is also treated as a similar data type that int32 is there, or let's say array slices. It is a similar data type that other variables are treated as. So you can pass functions to a function as well. So how you can do it? Let's see this with an example. Let's say I have two functions, multiply and addition, and those two functions will take in a variamatic inputs where it can take n number of inputs. So I have created a variable with name multiply, and the type by which it is declared is a func which will take an input of type variamatic and will return an int32. Now is equal to, again, the same function signature, and then we'll give the compute function definition, which will have the return statement as it was there in other functions. So this will be declared as normal function, where it will have some input values and it can have some output values. So I have declared a multiply over here and an addition over there. Now I have an execute function, okay, which will take a function as an input. So execute it is itself a function and is expecting a function argument to be passed in, and the function argument is of type where it will take in a function which can accept n number of values and will return a simple int32. And this execute will also take in all the values that it needs to be passed to this function. Now, when we declare this function, so we will be calling this function by passing all the values that are there in the passing value. So I have declared the name different in both places. That is why it's confusing. So it will be passing values. So these passing values will be passed to this function. Now this passing value becomes an slice that we have already learned, but the function will be expecting the values as variamatic inputs. So that is why we have given triple dot so that it breaks the the slice into its native elements and pass it to the function. Now I have an in main program, I will execute addition. This addition is a function which we have already declared. So I have passed a function and I have passed all the values that needs to be passed to this function. Similarly, I have also executed multiply with passing all the values. So we'll see how the output is. This approach is normally used when you have multiple functions, but you have an input from the user that what functions need to be executed. So in our case, let's say we would be expecting an argument from the user where he would say that do he want an addition or multiplication. Based on that input, we will decide that what function need to be passed in the ex execute function. Now let's understand and let's run this program. So the output is 15. So first was addition. So addition of 1 to 5 is 15, and then multiplication of 1 to 5, that is factorial 5 that you may say, is also 120. So this is how you can pass functions in a function. Okay, and you can also declare some anonymous functions in the main scope. So let's say I want to declare a function which will only which will only print some hello world for us right now. Print ln. This will only print hello world for us. Now, as we have declared this function and not executed this, the co-compiler will give us an error and say that the function literal executed but not used. So this function is actually not executed. So you should give a parenthesis in the end of the function declaration so that this is executed as soon as this is encountered. So when you see and run this program, so the output till here is finished and then we get an hello world again. So this can also be declared as a function over here, and the function can be executed separately in other blocks as well. So you can declare a function inside a function as well. This function can accept int values also, like int, and let's say hello world, and I'll print I as well. So this function is actually expecting an argument of type integer, so you should pass an integer into it. Let's see if it prints hello world space var. Yeah, you can see it prints hello world space var now. So you can have anonymous functions built. You can have functions declared inside a function, or you can declare functions outside the function scope and pass that accordingly. So these are actually declared as a global scope functions, which will be accessible by any other functions as well. So you can use this and you can pass functions inside functions. So that's all for the video today on functions. Thank you for watching the video. Please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications. Also do comment us below on any feedbacks or any new tutorials that you want us to do.